Hey guys, welcome to the Level 3 Calculus 2019 differentiation exam paper. The way this video works is I go through the answers, fully worked answers, and also we'll let you guys know what Achieve Merit and Excellence is. The best way for you guys to do this or watch this video is to pause the video at the start of each question, try the question out by yourself, and then check my answer just to see how far you went with the question. So without further ado, let's get started. All right, guys, so let's go to the first question here. So with question 1A, what we've got here is just your standard differentiation question. So what we're going to do is we're going to get rid of that square root symbol first, and we're going to rewrite this as 3x squared minus 1, and that's to the power of half. So once we do that, we can now differentiate it. So we're going to get y dash is equal to, bring the half in front. I've got 3x squared minus 1, and of course I've got to take away 1 from the power, and I've also got to multiply it by the differentiation of whatever's inside the bracket. So inside the bracket, when I differentiate 3x squared minus 1, I'm going to get 6x. So I am just going to multiply that 6x towards the end. Now, as you guys can see, it actually says you do not need to simplify your answer. And I'm just having a quick look at the answer schedule here. As you guys can see, the only kind of difference between my answer and their answer is they've actually went a half take away 1 as negative. Where is it? I got it there. Yep, half take away negative 1 as a negative half. But, you know, I reckon, I mean, one of the things is that you can just put a little bracket around here if you want to, just to stay safe. And I think that should get you an achieved grade for that question. All right, so let's go to question 1B. So with 1B, what we have is we've got to find the rate of change of this function when t equals to 4. So I guess all we have to do is we've got to try and figure out what the gradient is, really. That's all. So we are going to differentiate the function. So we've got f of t is 5 ln of 3t minus 1. So when I differentiate this, I'm going to get f dash of t. 5 stays as it is. Now ln, when you differentiate ln of x, you're going to get 1 over x. So in this case, when I differentiate ln of 3t minus 1, I am going to get 1 over 3t minus 1. And of course, I've got to multiply by the differentiation of whatever's inside that bracket. So in this case, it's going to be 3, because when you differentiate 3t minus 1, you get 3. And at this point, that is my gradient function, but I need to find out when t equals to 4. So I'm going to substitute t as 4. And what I've got is 5 times 1 over 3 times 4 minus 1 times 3. So in the numerator, I've got 15. And in the denominator, I've got 12 minus 1, which is 11. So 15 over 11 is what we're looking for. So this question, once again, is going to be an achieved question. And having a look at that answer schedule there, as you guys can see, you need a correct solution with correct derivative. So you do need both of them. I guess the reason why you need both the derivative and the answer is because you can actually use your calculator to get the answer. And I'll show you guys how to do this. So just go into menu, go into run mode, and then click on option, go into this calc button, which is F4. So click on that and see how this is d over dx. That gives you your derivative at any given point. So I'm going to put in my function, which is 5 ln of 3. Instead of t, I'm just going to use the x here. So 3x minus 1. Close my bracket twice, and then put a little comma, and 4. Basically, that's telling me that I want you to find the differentiation of this, substitute 4, and tell me what the answer is. And as you can see, you're getting 1.36. Now, 15 over 11, as what we originally got as the answer, is also the same, 1.36. And that is why you need the derivative and the answer. All right, so let's go to the next question, question 1C. So with question 1C, what we've got here is we've got find the gradient of the tangent to the curve, blah, 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 at the point where x equals to 2. So all we're really looking for is the gradient, all right? So we just got to differentiate and put x equals to 2 and figure out what it is. So the way we're going to do this is, because we've actually got something in, well, we've got a fraction here to work with, right? So we've got e to the power of 2x and 1 plus x squared. So if you want, you can kind of treat it like this: y equals to fg, and hopefully this gives you a reminder that you've actually got to use the quotient rule. So the quotient rule means that you're dealing with, what do you got? Y dash is equal to f dash g minus f g dash over g squared. So because I've got all of this on this side, I'm going to work it out here. So if f equals e to the power of 2x, then f dash is equal to 2e 2x. And then I've got g as 1 plus x squared, which means g dash is equal to 2x. So all I've done is I've just differentiated the numerator and the denominator there separately. Cool. So now let's put it into the f dash, like the y dash itself. So then I'm going to get y dash is equal to f dash, which happens to be 2e 2x. G is multiplied by 1 plus x squared, minus f now is e to the power of 2x multiplied by g dash, which happens to be 2x. And of course, all of this is over 1 plus x squared over 2. So at this point, just doing this right here will get you an achieved, because you've actually differentiated a function using quotient rule. And I guess now you got to try and figure out what the gradient is. So we've got to substitute x equals to 2 in this ugly looking equation and actually figure out what that value is. So what we've got here is y dash when x equals to 2. So that's going to give us 2e to the power of 2 times 2 is 4, multiplied by 1 plus 2 squared minus e to the power of 2 times 2 is 4, 2 times x is also 4, and that whole thing is divided by 1 plus 2 squared over 2. Now, here's the thing, all right? Like, I would actually put this as my substitution thing, but remember how I showed you guys how to use the calculator before? Just so that you don't have to type all of this in the calculator, you could actually use d of dx. All right, so we're going to use d of dx, which is here, and we're going to put down e to the power of 2x. So I hope this actually works out, because sometimes I try things and they don't work out. But e to the power of 2x, yep, and that's divided by 1 plus x squared. Just want to make sure I put all the brackets in the right place. And then I've got comma and, yep, at 2. So as you can see, it's giving me an answer of 13.10. So basically, I'm going to try and do this the long method here, which I've got at the bottom here. So I've got, in my numerator, I've got 2e to the power of 4 multiplied by 1 plus 2 squared is 5. So I'm just going to kind of do that. Minus 4e4. Oops, got the wrong one. And close bracket. And all of that is divided by 1 plus 2 squared is 5. 5 squared is 25. Well, I made a mistake somewhere. Where have I made a mistake? I think I know where. Here we go. Oh, really? Why is that? Ah, okay. Too many brackets. There we go. Sorry about that. See, I mean, you can actually make mistakes like this too. So I think 13.1 was what we had as the previous answer. But as you can see, I mean, I'm like using the calculator to actually do this question, and you know, you can make silly mistakes like this. But having that other thing that I talked to you guys about, where is it? So using this function here, using the calculator here, Boom, 13.01, 13.10, straight up the answer. So this answer here gets you guys a merit grade. So really, you want to make sure that you guys are careful when you're doing these types of questions, is that it's always a good idea to use the calculator to check your answers. Going to the answers itself, I forgot to show you guys that. So if we have a look here, yeah, so correct derivative is achieved, and then for a merit, what we have is that final answer, which is 13.10. Cool, so let's go to question 1D. So with question 1D, what we have is we've got for what values of this function decreasing. All right, now if you've forgotten what this is, decreasing is that the gradient function has to be less than 0. All right, so that's kind of like the first statement that we want to have. So f dash of x has to be less than 0 for decreasing. So this type of question comes in level 2 as an excellence, but in level 3 calculus it ends up being a merit, and you've got other things that you got to deal with. Like when I say the other things, I'm talking about the function here. So the function that we've got to deal with here is maybe I should have used something. I'll use u and v. So if I say u is equal to x cubed and v equals to e of x, I can see that it's actually two things that are getting multiplied here. So I've actually got to use the product rule. So then what I have is u dash is equal to 3x squared and v dash is equal to e of x. When I differentiate e of x, I'm still going to get e of x. So my f dash of x is then equal to u dash v plus uv dash. So what I've got is I've got 3x squared multiplied by e of x plus x cubed multiplied by e of x. And correct derivative gets you an achieved. So getting up to here is already going to get you an achieved. And then now we go into the rest of the question to try and get a merit here. So what we know is that this function has to be less than 0. And because it has to be less than 0, we've got, hang on. Technical issues. So because what we have is we've got this function has to be less than 0. What we've got here is 3x squared ex plus x cubed ex has to be less than 0, because that's what the decreasing function is. Now you're looking at this and going, geez, I've got e of x, and you know what? You got e of x on both sides. So take it out as a common factor. Plus, you got some x's, I think you've got x squared as a common factor. So you can take out both x squared and e of x as a common factor. What you're going to end up with is 3 plus x is less than 0. And remember that 0 divided by any number, it's 0. So we're going to rewrite this as 3 plus x is less than 0 divided by x squared e to the power of x, which means that's now going to be just 0. So rearranging this, we've got x has to be less than minus 3, which happens to be your final answer. So the grade that you're going to get for this particular question is a merit for that last bit. So a couple of things to remember. When it actually says, where is it? When it actually says decreasing, remember that the gradient has to be less than 0. And if it says it's increasing, then it's going to be greater than 0. So I think, yeah, that's pretty much what it says in the answer schedule. So let's go to question E. How much space have I given myself? Given myself a little bit of space. There we go. Okay, so with this question, what you have is we've got a volume of a sphere at an instant where the sphere's radius is 0.5, blah, blah, blah. Surface area is increasing at this. Find the rate at which the volume of sphere is increasing at this instance. Now, if you've been kind of trying these questions with rate of change, is that, especially if you see a rate of change question as question E, it usually ends up being like I call it a triple threat rate of change question because it's like there's three elements that you got to work with. So I guess the best way to go about this is that, write down what you actually are looking for first. So if you look at the question, the rate at which the volume, okay, so we are actually looking for this thing here, which is the rate at which the volume is changing. So we're looking for dV dt. Now the things that we've been given is surface area is increasing at 0.4 meters squared. So we know what this sentence here is going to be, and I'm going to kind of write it down here separately. So we know that dSA of dt is equal to 0.4. So that's actually from this part right here. All right, so we've got the surface area over dt. We also know it is when the radius is 0.5. So that's a really important part here. The radius is 0.5 meters when all of this is actually happening. So this is all the information that we've been given, and we're looking for dV dt. So here's how it's going to work, all right? So I'm going to write down this equation as is, dV dt. Now, I know that I've got ds over dt, right? So we're just going to fit in here somewhere. ds surface area, so I'm just going to put it as dSA over dt. And I also know this is a volume of a sphere. So volume of a sphere is equal to 4/3 pi r cubed. Now remember, this formula is given to you in your formula sheet, and I know that if I differentiate the volume function, I'm going to get dV dr equals to what I got. 3 comes in the front, 4/3 pi r squared, which means dV dr is equal to 4 pi r squared. So that's something that I'm going to need. And I also going to need the surface area with radius. All right. And so I know that the surface area of a sphere is equal to 4 pi r squared, which means dSA of d over dr is going to equal 8 pi r. Now the reason I wanted dSA dr and dV dr is because that's what I'm going to put in this in here to kind of figure out what dV dt is. Because if you think about this, if I want dV dt, I can't have dSA, which means dSA has to go in the denominator somewhere. And the only other one that I have is dSA dr, which I can actually flip it upside down. And now I've got to get rid of that dr, so dr is going to come in front here, and that's going to end up with dV. Now, I completely understand if you're like, where did he get that from? All right. The other way of looking at it is almost think about it like this. In the left-hand side, I have dV, which means in the numerator, I need a dV. All right. Because that's how I'm going to get the two equations to actually match up. And the only thing that I have is dV dr, which is from here, that I can actually bring up. Now that's going to get multiplied, but now what I have is I've got dV, and in the denominator on the left-hand side, I need dt, which I have, which means I need to get rid of dSA and dr. Notice how the dSA and dr is kind of stuck there by itself. So that's where I end up using this equation, because by using this equation and flipping it upside down, what you'll notice now is that dSA and dSA are going to kind of, they disappear in a sense, and also dr and dr disappear, which means I've only got dV dt. Now this is probably the challenging part of this question, but if you can get this question, this part of it that's in the yellow box, right, then the rest of the question is just literally a walk in the park. So what do we have here? dV dt equals dV dr. Now that's 4 pi r squared multiplied by dSA dt, which equals to 0.4, multiplied by dr dSA. Now that's going to be 1 over 8 pi r, because we needed to actually flip it upside down. So if we flip it upside down, what we've then got is we've got a whole lot of cancellations that's going to be happening at the moment. First, I'm going to get rid of the 2 pi's. They're going to cancel out each other. Then I've got to get rid of the r with 1 r. And so 4 and 8, so I can replace it with 1 and 2. And of course 2 and 0.4, get rid of that as well, and I end up with 0.2. So really, I end up with 0.2r as my dv dt equation. And because r is equal to 0.5, I can actually say dv dt equals 0.5 times 0.2, which equals 0.1 meter cubed per second. Now, if you're unsure about the units, always remember you're dealing with volume, so that's going to come up in cubics meters. And because you're dealing with time, in this case it's going to be seconds, that's what you're going to end up with for seconds. Now, you're probably wondering, can I actually do those calculations in the calculator straight away instead of trying to do this? Yes, of course you can do it, because all you needed to do was, well, first let me grab the calculator. We just needed to go r is equal to 0.5, so we're going to go 4 times pi times 0.5 squared multiplied by 0.4, and that's equal to this, blah, 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 divided by 8 pi r. So 8 pi and r is equal to 0.5. So there you go, 0.1. That's another way you could do it as well. So let's have a look at what you're going to get for grades wise. So grades wise, correct expressions for ds, dr, and dv, dr. So you could potentially get an achieved, but you have to get both this and this correct. Line 5, 1, 2, 3, 4, 5. Correct expression for dv, dt gets you a merit. So I guess this part here gets you a merit, or I think all the way up to here, because anything equivalent line 5 is okay. And finally, excellence is getting that 0.1. Now, if I show you guys the schedule here, as you can see, it says units not required. So, you know, just getting that correct solution with correct derivatives is going to get you an excellence for this question, which actually ends up being 8 points. Because as you can see, E7 is minor error, E8 is like full 8 points there. All right, so we are going into, I think that's it for question E. Yep, that's question E done there. All right, guys, we are heading into question 2. All right, guys, so with question 2, what we have is we've got a lovely problem to start off with. All right, so we're just differentiating this. So as always, I'm just going to write the equation down, differentiating it. I'll bring the 4 in front. So I've got 2x minus 5 to the power of 3. And of course, I've got to multiply by the differentiation of whatever's inside the bracket. So differentiating 2x minus 5, I'm going to end up with 2. And that is it for this little question. Kind of nice, achieved. And we can actually move on to the next question. So with the next question, what we have is we've been asked to find the gradient of the tangent. So again, we're not finding equation, just finding the gradient of this particular curve at pi over 6. So I'm going to write down as f of x is equal to tan 2x. So when I differentiate tan, I'm going to get sec squared 2x. That's always a hard one to say. Sec squared 2x. And of course, I got to multiply by the differentiation of whatever's inside the bracket. So in this case, it's going to be 2. So my function is, gradient function is 2 sec squared 2x. And of course, I got to substitute pi over 6 to actually try and figure it out. So I got to go f dash of pi over 6 is, now remember that your calculator can't actually do sec squared, so you got to do cos squared. So this is going to be rewritten as 2 over cos squared 2 times pi over 6. And we're going to try and figure out what this is. First things first, I want to make sure that my calculator is actually in radians in this case. That's the worst thing you can do. Yes, that's in radians. That's fine. What do I got? 2 pi over 6. So I'm going to do cos of 2 pi over 6 is the same thing as, let's just do it the long way. It's fine. 2 pi divided by 6 equals to this. Squared of that equals to this. And then 2 divided by the answer is giving me 8. Now, as I said to you guys in the previous question, what you could have done is just click on Option, go into Calc, d of dx, put in tan 2x, so tan of 2x, and we're going to put pi over 6 as our x value. And as you can see, voila, you get that 8. Grades-wise, this question here is going to get you an achieved. But like that previous question that we did in 1B, you need the differentiation and the answer correct to actually get the full achieved mark. Fun times. Okay, so we are going to question C. So what we've got is we've got a parametric equation and we need to find out the gradient of the tangent. Well, so what we're going to do is we're actually going to work out what dx dt and dy dt is, and then put them together as dy dx. So we're going to do the x part first. So x is equal to, I hate when that's like this. So what I'm going to do is I'm going to bring 5 minus t to the numerator, and I'm going to rewrite this as 5 minus t to the power of negative 2. So dx dt is equal to negative 2 multiplied by 5 minus t. Now minus 2 minus 1 is negative 3. And of course I got to multiply by the differentiation of 5 minus t, which is negative 1. Simplifying this, I'm going to get 2 5 minus t to the power of negative 3. You know, considering that this is one of those cross multiplication questions, I don't really want to deal with negative powers. So I'm going to bring it to the denominator and I'm going to make it positive 3. So that's my dx dt complete. Then I need my dy dt. So if I go into y is equal to 5t minus t squared, so dy dt is equal to 5 minus 2t. Now, interestingly enough, I'm just having a look at the answer schedule. You get an achieved if you get dx dt correct. But if you get dy dt, there's like nothing. They only want dx dt for an achieved. I guess dy dt is kind of like at that level 2 calculus level, so they're not really worried about it too much. So let's see what dy dx is. Dy dx will be dy dt multiplied by dt dx. So my dy dt, which is that, and dt dx, well, I've got to flip this upside down to get dt dx. So I'm going to end up with 5 minus 2t multiplied by 5 minus t cubed over 2. So at this point, I've got t equals to 2. So my dy dx is equal to 5 minus 2 times 2 multiplied by 5 minus 2 cubed over 2. And let's just use the calculator for this one. Now you're thinking, can I actually use that dy dx? Well, we can't, because we actually don't have the original function, which is y. So that's why we can't actually do the whole calculators thing. So this one, you got to do it the long way. So we've got 5 minus 2 times 2. What else do we have? Multiplied by 5 minus 2, which is 3 to the power of 3 equals to this, divided by 2 equals 13.5 as my final answer. So the correct answer is going to get you guys a merit here. I'm going to show you guys just the answer schedule real quickly. As you guys can see here, like, look, correct expression for dx dt. So they really don't care whether you get dy dt correct or incorrect for that achieved. So for the achieved, they're really making sure that you guys can actually manipulate this type of equation and differentiate it. All right, so let's go back to the question 1D. Lovely when I get a question that I can't actually fit in the screen. But let's just see. That's the best I could do at the moment. Okay, so this question here, what we've got here is, well, I'm not sure why there's a YouTube link in that question for starters. That's, yeah, I don't think I want to go to that right now, but let's just focus on this question. Basically, what we've got here is we got a bridge that's rising. The bridge's arm is 22 meters, and we want to know the horizontal increases at 0.01. Okay, so our first bit of information that we have is this thing right here, 0.01 radians per second. Now, that could be this theta here. So we could actually say something like this, d theta over dt equals to 0.01. That's the first thing. Now it says the question, find a rate at which the height BH is increasing when h is 15. Okay, so we are looking for, the moment it says rate and height, we're actually looking for dH dt. So if you have a look at what we've got here, we are looking for dH dt. And remember that question 1E we did. So we want dH dt. What we've been given is d theta dt. And let's have a look at what we have on the left-hand side. So that means we got to have dH on the numerator. So I need to have dH on the numerator. And in the denominator, I already have the dt, which means I need to get rid of the d theta somehow. Because if I get rid of it, then what's going to happen is I actually have dH dt. So I need to come up with an equation for h, which is this part right here, in terms of theta. And so, and I think, you know, just looking at this triangle right now, you can kind of see what's happening here. Because what you have is you've got theta here, and you've got this distance as 22 meters, and you've got h. And, you know, straight away at this point, alarm bells should start ringing in the sense where you're dealing with some basic trigonometry here. So if you think about it like this, what was h? H was 15. Okay, so we're trying to figure out d theta dt at 15 meters. So the first thing we're going to do is we're going to rewrite this. So in a sense where I know h is there and it's going to be confusing for people, but if you think about it, this is actually opposite, and this is your hypotenuse. So you're actually using sine. So sine theta is equal to opposite over hypotenuse. Now, again, it's so annoying that they use little h and you've got hypotenuse as h, but just bear with me on this one, all right? So what we can then do is we can write sine theta, opposite ends up being little h, and the hypotenuse is 22. So then we can say that h is equal to 22 sine theta. And because h equals 22 sine theta, we can now differentiate this to get dH d theta, which means we're going to end up with 22 cos theta, because remember, when you differentiate sine, you actually end up with cos. And I believe we've got everything that we need here, because now we can figure out what dH dt is. Now d theta dt is 0.01 multiplied by dH d theta, which is 22 cos theta. But here's the thing. What we don't know is we don't know what theta is when the height is 15 meters. So remember that we're trying to figure out at what rate is the angle changing when the height is 15 meters. So we've got to figure out that theta first. And so to do that, I'm going to go back to sine theta, opposite over hypotenuse, so it's 15 over 22. Then theta is equal to inverse sine of 15 over 22. So that's going to give me whatever theta is. Get my calculator. Shift sign of 15 over 22. Okay, so that's giving me 0.75. So theta is 0.75. Now I go back to dHdt and I substitute that 0.01 multiplied by 22 cos, because I figured out what that angle is, which is 0.75, I can actually figure out what dHdt is. Now I'm going to use 0.75 as an answer function, so I'm going to leave it as it is. So I've got 0.01 multiplied by 22 cos of answer. And that's giving me 0.16, well, if you want, 0.161 meters per second. So, grades-wise, correct expression for dHd theta gets you an achieved. So that is right here. This gets you achieved, and then correct solution with correct derivative, units not required, gets you a merit. So with this question, you know, in first glance there, this question looks a bit crazy, but truth be told, it's you know, when you break it down like this, it is a lot more simpler. So, you know, I'll be honest, when I first had a look at this question, I was like, what the hell are they talking about? But as you read through it, you start getting those little hints of what you need to do. You know, and in fact, it wasn't a challenging rate of change question. It just had like a couple of extra bits to it. All right, so let's go to question E. Well, that's going to be a fun little question, isn't it? Well, in hindsight, this question is not challenging. It's just long. So we've got basically a proof question here, right? So we've got to prove that d squared y over dx squared equals to that rest of that ugly looking thing there. But in fact, this question is actually not too bad, because all you got to do is just differentiate things the right way. So what I'm going to do is I'm going to do the left-hand side first. So to do the left-hand side first, I need y in terms of x. All right, now I know that u equals to sine of x, no, sine of 2x, and y is equal to e to the power of u. So what I'm going to do, my first thing is I'm going to substitute u into the y equation so that I can actually work out dy dx, d squared y dx squared, so because I've got to differentiate that twice. So if I write y equals e to the power of sine 2x, now I got to differentiate this. So differentiating it once, I'm going to get e to the power of sine 2x multiplied. I got to differentiate sine 2x. And when I differentiate sine 2x, I'm going to get cos 2x. And of course, I've also got to multiply by the differentiation of whatever's inside that bracket, which is going to be 2. So that means dy dx equals to 2 cos 2x e of sine 2x. So far, so good. By the way, that gets you an achieved right there. So yeah, but that's not what we're going for. We're going to keep going with this question. We need to actually work out what the differentiation of this now is. The problem is we've got two functions, and so we've actually got to use product rule for this. So what I'm going to do is I'm going to call this f and I'm going to call this g, which means f dash is going to equal, I've got to differentiate 2 cos 2x, so I'm going to end up with 2 cos. When I differentiate, I'm going to get negative sine of 2x, and of course I got to multiply by the differentiation of that, which equals to 2, which means f dash equals negative 4 sine 2x. And as for g, well, g part I don't really need to differentiate again, because remember that's what dy dx is. but just in case, I'm just going to show you guys, because when I differentiate e sine 2x, remember that this is the same thing as what we did here. So the answer that we're going to end up with is pretty much what we did here. So it's going to be 2 cos 2x multiplied by e sine 2x. Okay, so let's actually put down d squared y over dx squared is equal to f dash g plus fg dash. Now f dash is negative 4 sine 2x. G is e to the power of sine 2x plus f, which happens to be 2 cos 2x multiplied by g dash, which happens to be also 2 cos 2x e to the power of sine 2x. Now I can simplify this a little bit, and I can put down negative 4 sine 2x e to the power of sine 2x plus 2 cos 2x squared e sine of 2x. So all I've done here is just the left-hand side at the moment. Now I got to work on that right-hand side. So this was the left-hand side. Right-hand side, geez, that looks uglier than usual. Just going to copy that down first. So u equals sine 2x and y is equal to e of u. Let's see. So I've got to work out d squared y. Oh, jeez, this is just super painful, isn't it? Doesn't matter. It looks like I have to differentiate them twice anyway. Yeah, so I got to differentiate them twice anyway. So I might as well do that. Which means when I differentiate du dx, I'm going to get 2 cos 2x. That's fine. Differentiate it again, and I'm going to get 2 times negative sine 2x multiplied by another 2. Just a reminder that 2 is from there. Well, talking about this 2. Then I've got dy du equals e of u. That's not too bad. D squared y du squared is also equal to e of u. So that's nothing too bad so far. Now I need to get that right-hand side out. So the right-hand side was d squared y du squared du over dx squared plus dy du times d squared u dx squared. Okay, so let's do this for the right hand side. So d squared y du, that's going to be e of u, multiply du dx is 2 cos 2x squared plus dy du is e of u, and d2u dx, that is actually multiplied by 4, well, it's negative 4 sine 2x. Now, because u is equal to sine 2x, we can actually rewrite this as e of sine 2x multiplied by 2 cos 2x squared plus e of sine 2x. Yeah, as you can see, my head is like right down trying to figure this question out. Multiplied by negative 4 sine of 2x. And I believe we have them equal to each other for the right-hand side. Let's just double check it. So first things first. I've got e sine 2x, which is that part there. And I have negative 4 sine 2x, which is that part there. Then I've got e sine 2x again, which happens to be there. And finally, 2 cos 2x squared, which happens to be there. So I can say, therefore, left-hand side equals right-hand side. I might actually just put down here that this is right-hand side and this is left-hand side. So as I said, not a bad question, but just a long question in terms of trying to work it out. Um, what do you get for grades? Okay, let's have a look for grades. So if you actually get dy dx or du dx, really? Okay, so you get an achieved either for getting this correct or this correct. So that actually gives you an achieved. Merit is correct expression for d squared y dx squared. So that is this one here gets you potentially a merit or correct right hand side. Okay, so either one of them gets you a merit. So either one of the sides, getting one of the sides. And then if you complete the proof, you actually end up getting an excellence. Basically, guys, that is it for question 2E. Yeah, it was a strange question 2E, because I mean, apart from the fact that it's actually really long, it's not a bad question to do. But yeah, so that's basically it for question 2, and then we go to question 3 next. All right, guys, so back to some more nice simple questions here, but we've got question 3A. So two ways of doing this. You could potentially use quotient rule if you want to, but that's going to take a bit of time. What you can do is rewrite this as 4 and bring sine x to the numerator and put it into power of -1. So when we differentiate this, we're going to get 4 multiplied by -1 sine x. -1 minus 1 is -2. Or you can leave it like this and multiply it by differentiation of sine x, which happens to be cos x. So simplifying this, if you want to, is -4 sine x to the power of -2 multiplied by cos x. So this question here gets you an achieved. And we go to the next question, question B. It's a pity this question has actually been converted to an achieved question, because for the last kind of, I don't know, 6 years, it came up as a merit, but now they've actually converted this to an achieved. Hopefully this year they change it back again. But anyway, so the way we do this question is find all the values, meet the criteria, f dash of x is equal to 0. So we are looking for the gradient. When is the gradient actually equal to 0 in the graph? So this is for question 1. Well, B1 part 1. So the gradient is equal to 0 right here because it's a flat line. So that's when x equals to 2. And the gradient is also 0 when it's along this flat line after 4. So that means we've got to write it as x is greater than 4. Then the second question is this. What we have is, second question is f of x is not differentiable. So that means where are the corner points and where are disconnected areas as well. So we can say that it's at -2, +1, and 4 because it's a corner point right there. So we're going to write this as -2, 1, and 4. And of course, a final question is what's the value of lim of as x tends to 1? As you can see, when x tends to 1, both of these are heading towards 2 different points. So we basically just say it does not exist. So those are your 3 questions there. To get an achieved, 2 correct solutions. So that's what they're saying. And I think, to be honest, they've kind of complicated the schedule a little bit here, because it says, I'll show you guys the schedule. So we were given 3 answers, right? Like, so you got 2 answers, 3 answers, and then, so altogether there's 6 answers. But then they say 2 correct solutions. That is 2 of 1, 1, 1, 2, and 2. What the? 2 of 1. Yeah, I'm struggling to understand how that is working out. 2 of I, 1, I2 and 2. Yeah, my suggestion is try and get all those questions right. All right, don't leave anything to chance here. Because seriously, that schedule is like, it's driving my head in to try and understand what that's asking. Anyway, let's get going to question C. So question C, what we have is we've got a rectangle, blah, 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 opposite vertex. Let me guess, maximum area. Okay, so to figure out what the area of this rectangle is, we've got base times height. All right, any area of a rectangle is always going to be base times height. Now the thing is, this is what you guys need to understand. This and this part here. If this is x, remember that this point here, this green point, becomes x and f of x. So it's kind of like saying that x ends up being the base and f of x becomes the height. Because along that point, anywhere that you go along that curve, you're actually going to get the height of the rectangle. And to get the point on the curve, you're going to use f of x. So what we have got here is area equals base, which happens to be x, multiplied by height, which happens to be 4, minus root x. So at this point, this is our equation for the area. So we're going to expand it. We're going to get 4x minus. Now remember that x is, square root of x is x to the power of half. So we're going to get x to the power of 1 times x to the power of half. So area is equal to 4x minus x to the power of 3 over 2. So if this is the case, we can now differentiate this. So when we differentiate this, we're going to get 4 minus 3 over 2x and 3 over 2 minus 1. So a dash is going to end up equaling 4 minus 3 over 2 and x to the power of half. So correct expansion for this, correct expression for the area gets you an achieved. And now we need to figure out what the maximum possible area is. So we're going to put down that this happens when a dash is equal to 0, which means we're going to get 4 minus 3 over 2 x to the power of half is equal to 0. So we're going to start rearranging things. Equals minus 4. And then root x is equal to minus 4 times 2 divided by minus 3. So root x is equal to positive 8 over 3. Let me just double check. Which means we can actually say that x is equal to 64 over 9 because I want to square it. But the question actually asks us what is the maximum area. So we got to go back and substitute that 64 over 9 as x. So what we have is, remember that base times height. So base times height was, what was it, 4 minus root x. So we're going to get 64 over 9 multiplied by 4 minus 8 over 3, because square root of 64 over 9 is that. And we're going to end up with 9.48. But let's just kind of do that quickly anyway. Always click on the wrong calculator. So 64 over 9 multiplied by 4 minus 8 over 3. So 9.48 is the maximum area you could actually get. Correct solution with correct derivative gets you guys a merit. But as I said, achieved is for the area function differentiated. All right, on to question D. So with question D, what we've got is we've got velocity of this object, blah, 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 t. Find the time when acceleration of the object is 0. Okay, so we've got velocity function. which means we differentiate it to get the acceleration function. So let's do that. Plus 8e to the power of negative t. So acceleration is then going to equal 2et. When I differentiate, it's still going to be 2et plus 8e negative t multiplied by the differentiation of the power. In this case, it's going to be negative 1. So what we've got here is a is equal to 2et minus 8e negative t. By the way, guys, doing this gets you an achieved. So now we want to know when is the time, what time when the acceleration is equal to 0. So, well, we just have to put 0 equals to 2et minus 8e negative t. So rearranging this, what I'm going to get is 8e negative t equals 2et. And then I've got 8 over 2 equals e of t divided by e of negative t. So remember that 8 over 2 is equal to 4. And because e is got the same base, we can actually subtract the powers. This is very similar to what we do, you know, when we have something like this, a to the power of m divided by a to the power of n. Then you would just subtract the powers. So that's exactly what we're doing here. So we're going to get e to the power of t minus negative t, and we've got 4 equals e to the power of 2t. And at this point, I'm going to take a log of both sides. So ln of 4 equals ln of e to the 2t is just going to be 2t, and t is equal to ln of 4 divided by 2. Now you can actually leave the answer as this, but if you really want to be how do I call it? You want to be sure about it, then just chuck it in the calculator. So we've got ln of 4, and that's divided by 2, which gives you 0.693 seconds. Seconds? Yep. And correct solution with correct derivative gets you a merit grade. Okay, so let's go to the last question of this paper. All right, guys, so for this question here, what we're going to do is, let me actually see if I can kind of point this out. So the first thing is this, right? We've got this curve. We know that at point P, it's going to have a gradient function. So that's the first thing we're going to do. We're going to try and figure out what the gradient function is. Once we figure out the gradient function, then there's a couple of tricks that we can do. Because it's a straight line, we can actually do a couple of tricks. So the first step I'm going to be doing is find the gradient function. Because f of x is equal to 2, 36 minus x squared to the power of half, I'm going to work out what f dash of x is. So that's going to be 2 times a half. 36 minus x squared. A half minus 1 is negative half, multiplied by the differentiation of whatever's inside the bracket, which happens to be negative 2x. And when I do this, it's a good idea in this case to actually start simplifying some of these terms. So 2 and a half kind of disappear, and what I'm left with is f dash of x equals minus 2x. And in the denominator, I'm going to get 36 minus x squared to the power of positive half. And of course, that could be rewritten as negative 2x over square root of 36 minus x squared. So this is the gradient function of that parabola that we actually have got. All right. Well, it's not really a parabola, whatever that function is. So the next thing is this. Whatever the value of p is, we don't know the x value of p, right? That's what we're trying to figure out. So what I'm going to do is I'm going to call the x value of p, little p, for example, just to give you guys a bit of an idea, right? That means the point is f of p. All right, so whatever p is, then if I substitute it into the equation, I'm going to get f of p. The other thing I also know is this part right here. So remember how we can actually work out gradient as rise over run. So what we also know is we can actually say this part here is rise, and this part here is going to be the run. So if I was to call this from here to here as, just bear with me on this one, all right? If I call this x, then the blue part here is going to be 8 minus x. I hope you guys can see that. Then the second part is, if the yellow part is the height or change in y, we know the yellow part is the same thing as saying f of x. So in other words, what we've actually said is the gradient m equals change in y over change in x. Now the change in y part is highlighted in yellow, which happens to be the original function, which is function of x. So that there, I could actually rewrite this as the gradient is equal to 236 minus x squared divided by change in x. Now the change in x part is this part, which is 8 minus x. So what I've got here is the gradient is actually equal to 2, which is 2 root 36 minus x squared divided by 8 minus x. Now the only other thing to keep in mind is that this is actually going down. The straight line is actually going down. So we need to make sure we add a negative sign in front there. So this is what the gradient of that tangent is. So the straight line right there is going to have a gradient because you've got change in y, which happens to be f of x, and change in x, which happens to be the blue part, which is 8 minus x. So we've got an equation for the gradient, which is this thing right here. But we also know what the gradient is equal to from the gradient function. So in other words, what we can actually say is those two green boxes are equal to each other, because the first green box is the gradient function, the second green box is the actual gradient itself. And so what we're going to do is we're going to put both of these two green boxes together. So we got negative 2x is equal to square root of 36 minus x squared equals negative 2 36 minus x squared over 8 minus x. So at this point, we are going to cross multiply and start getting rid of a few things here. So first thing I want to get rid of is the negative 2, because there's negative 2 on both sides. Get rid of them. So I've got x left over, and I'm going to multiply by 8 minus x equals square root of 36 minus x squared multiplied by square root of 36 minus x squared, because all I'm doing is I'm just cross multiplying things at the moment. So this now is going to give me 8x minus x squared equals 36 minus x squared is just, well, square root of that times square root of that is just going to give me 36 that. So x squareds now cancel out each other. And what I'm left over with is 8x squared is equal to 36. Sorry, 8x, not 8x squared. And from here, I can say that x is equal to 36 divided by 8, which equals to 4.5. All right, so it's a funny question, this one, because I think if you understand the principles of gradient, of how it works, then it's actually not a bad question, but it's just kind of thinking that one little extra step to try and make sure you get that gradient right. So in terms of let's see, grades wise, dy dx of curve gets you an achieved. So that part there gets you an achieved. Correct dy dx and correct gradient of tangent or tangent. So I guess something like this could get you a merit for getting this and this. And finally, getting that 4.5 as your final answer is going to get you that excellence by the looks of it. So yeah, bit of a weird question in terms of how it actually came about, but I mean, when we actually completed the question, you can kind of see it was, it's just something that you have to keep doing again and again, so you get like different styles of these types of questions. But ultimately, it's just understanding that, when you have a gradient function, you could actually use change in y over change in x to actually figure it out as well. Okay, cool. So that's basically it for question 3E. Hey guys, that is basically it for this video. As always, don't forget to like this video, share this video, and of course, subscribe to keep up with the latest content. There should be some playlists popping up. Check them out. Good revision material. And as always, thank you for watching.